Hi everybody. In this video I'm going to tell you about forms of a conditional. As you know already, a strict conditional takes this form: if P, then Q. But every conditional has a converse, an inverse, and a contrapositive. We need to study those forms and see the relationships that they hold. To get the converse of any conditional, you switch the hypothesis and the conclusion. That would become if Q, then P. And I would say loud and long, these are not logically equivalent statements. Many people confuse them, but they do not say the same thing. To get the inverse of the original conditional, I won't switch the terms, but I'll negate them. To get the inverse of this conditional, it would be if not P, then not Q. That's an interesting conditional. It is different from the other two, and we're going to practice writing those kinds of statements in a moment. There is one last one. Let me remind you, to go from a conditional to its converse, you switch the terms. To go from a conditional to the inverse, you negate the terms. What might you do to get the contrapositive? Yeah, you switch them and you negate them. So the contrapositive of this condition would be if not Q, then not P. We will show truth tables that will make this obvious to you, but at this time let me tell you that a conditional is logically equivalent with its contrapositive. That is to say, if this statement is true, this one must be true. They say the same thing. If this one is false, the conditional is false, then the contrapositive is also false. Likewise, the converse and inverse are also logically equivalent. If I know that the converse is false, I can assume that the inverse is also false. Those things go hand in hand. There is one more form of a conditional that we should study. It's called a biconditional. And that happens when a conditional is true, if P then Q is true, and its converse is also true, if Q then P. A very powerful statement called a biconditional. If the conditional is true and its converse is true, then in fact all four of these forms are true, and we have the biconditional. The biconditional is best written this way, as opposed to this clumsy statement, P with a double arrow Q. And how do you read that statement? You read that P, if, and only if Q. That's the form of a biconditional. If a statement is true, a conditional is true, and its converse is true, you can combine them to make a biconditional, and the biconditional will also be true. This page is available at Canvas. I'm going to walk through this thing and do it as smoothly, as quickly as I can to make you understand how this would work. We start with this conditional. If two angles are vertical angles, then they are congruent. I accept that to be a true statement. Let me just tell you that's true. But then it asks me to write the hypothesis and the conclusion. I've already done that. If two angles are vertical angles, then they are congruent. The hypothesis is what follows the if. The two angles are vertical angles. I will not include the if when I write the hypothesis. I would just, what follows the if, the two angles are vertical angles, and the conclusion is they are congruent. I'm supposed to write the converse of that conditional next. And the converse of that conditional, I would switch the hypothesis. The hypothesis was two angles congruent. Two vertical angles, then they are congruent. If I switch the hypothesis and the conclusion, I will have the converse. If two angles are congruent, then they are vertical angles. What do you think about the truth value of that? If two angles are congruent, must they be vertical angles? And I'd say that's false. Here's an example of that. The base angles of this isosceles triangle could be congruent, but they're not vertical. So I could show angles that are congruent that are not vertical. Therefore, I say the converse is false. Well, the conditional was true. So these two are not logically equivalent. Let's go further. To get the inverse of a conditional, you negate the hypothesis and you negate the conclusion. And it would look like this. If the original condition were if P then Q, the inverse is if not P then not Q. And I've written the inverse of this original conditional. If two angles are not vertical angles, I negate the hypothesis, then they are not congruent. And we should wonder, is that a true statement or a false statement? If angles are not vertical angles, then they're not congruent. I would say, well, these are not vertical angles, but they are congruent. Therefore, I know that this is also a false statement. Turns out that the converse and the inverse are logically equivalent, and therefore I know if this were false, this would have to be false. There's another form called the contrapositive. To get the contrapositive of the original conditional, I switch the terms and I negate the terms. It would say, if not Q, then not P. And here I've written the contrapositive of that original conditional. If two angles are not congruent, then they are not vertical angles. And I hold that to be a truthful statement. That is true. As the original conditional was true, the contrapositive is also true. They are logically equivalent. Whenever the conditional is true, its contrapositive must be true. If two angles are not congruent, they could not be vertical angles because all vertical angles are known to be congruent. And that finishes the first exercise. The second one talks about this statement. If you're born in Galveston, then you're a Texan. I'm supposed to write the converse, inverse, and contrapositive. And you're going to do that same kind of thing a lot on this exercise. But rather than you watching me writing it, I just typed those things already. Here's the original conditional. If you're born in Galveston, then you are a Texan. And I should write the converse. First off, do we think this is a true statement? If you're born in Galveston, then you're a Texan? I say that's true. If you're born in Galveston, you must in fact be a Texan. But if I switch the hypothesis and conclusion, if you're a Texan, then you're born in Galveston, that's false. I could be born in Lubbock and still be, if I'm a Texan, I could be born in Lubbock. I don't have to be born in Galveston. I consider that to be a false statement. For the inverse of the original conditional, I won't switch them, but I'll negate them. It says, if I'm not born in Galveston, then I'm not a Texan. Would you consider that to be true or false? If I'm not born in Galveston, I could be born in Lubbock, then I'm not a Texan. Well, that's false. And again, I should recognize if the conditional is false, the inverse must be false, as they are logically equivalent. And the last one, to get the contrapositive of this original conditional, I'll switch the terms and negate them. What would it look like if I were to write that out? It'd look like this. If you're not a Texan, then you're not born in Galveston. Is that true or is that false? If I'm not in the group of people born in Texas, then I'm not born in Galveston. I would say that's a true statement. I also remember that a contrapositive is logically equivalent with the original conditional, and says if it was true, this one must be true. It just makes sense that it would have to be true. There's more to consider on this page, though. Let's look at this next one. If two angles measure sum to 100 degrees, then those angles are not complementary. That's a true statement. If they sum to 100, they can't be complementary because complementary angles add up to 90. But what am I supposed to do with this? I'm going to look at the converse, inverse, and contrapositive and decide which would be valid. And I'm going to write them out for you here. I've already done that. I'll show you them right away. One moment, please. Here we go. Here's the original conditional. If two angles measure sum to 100, then those angles are not complementary. That's true. Because to be complementary, you got to add up to 90. What would the converse of this be? If two angles are not complementary, then they sum to 100. Is that true or false? I'd say it's false. Lots of angles are not complementary. Like a couple of 60-degree angles are not complementary, but they don't sum to 100. So I got to consider that to be false. And then I'm going to take this original conditional and write its inverse. To get the inverse, I don't switch the terms. I don't switch the terms, but I'll negate the terms. So here it is, the inverse. If two angles don't sum to 100, then those angles are complementary. They're not complementary, then they are complementary. If two angles measured don't sum to 100, then those angles are complementary. No, that's not true. That's a false statement. If two angles could sum to 120, they're not complementary. So I'm going to say that is a false statement. But let me look at the contrapositive of this original statement. If two angles measure sum to 100, then those angles are not complementary. I'm going to switch the terms and negate them. If two angles are complementary, then those angles do not sum to 100. And I'm going to tell you that's a true statement. Lots of reasons to think that through, but I also know that a conditional and its contrapositive are logically equivalent. This must also be a true statement. If angles are complementary, they don't sum to 100. They got to sum to 90. One more thing for us to look at here. It's kind of a good example. I hope you'll look at it with me. The last question says, consider the statement, all teenagers are at least 13 years old. On the back of the page, write the statement as a conditional. Then write the converse, inverse, and contrapositive. Decide which of these statements are true. If one is false, give a counterexample. Show you why you think it's false. Rather than writing that out in front of you, I've typed it. But take a look at it with me. Here's the original statement. All teenagers are at least 13 years old. First, I got to write that as a conditional, as an if-then statement. And it would be, if you are a teenager, then you are at least 13 years old. I think we can agree that's a true statement. All teenagers are at least 13 years old. That's true. And then let's write the converse of that. To get the converse, I'll switch the hypothesis and the conclusion. And it would say, if you're at least 13 years old, then you're a teenager. Is that true? I got to tell you it's false. I'm at least 13 years old, but I'm not a teenager. Lots of people are at least 13 years old. They might be 25 years old, but they're not a teenager. So I got to say that the converse was false. If I wanted the inverse of this original conditional, if you're a teenager, then you're at least 13 years. If you're a teenager, then you're at least 13 years old. Mark it. To get the inverse, I won't switch them, but I'll negate them. If you're not a teenager, then you're not at least 13 years old. Hey, I'm not a teenager, but I am at least 13 years old. So I got to consider that false. And one more example, please. The contrapositive of this original conditional, I should switch the terms and negate the terms, would say, if you're not at least 13 years old, then you are not a teenager. Is that true? I say that it is. If you aren't 13 yet, then you're less than 13, and then you are not a teenager. That is true. Another quick thought would be that since the conditional was true, its contrapositive must be true, as they are known to be logically equivalent.